All right, this is part 2 of the using the Pythagorean Theorem lesson, section 7.5. And so in part 1, we talked about how to tell whether a triangle is a right triangle, an acute triangle, or an obtuse triangle by using the Pythagorean Theorem. And today we're going to use the Pythagorean Theorem some more, but we're actually going to talk about the distance formula, which is a version of the Pythagorean Theorem. And so to get us warmed up for this, I've got a coordinate plane here, and it says choose 2 points in the coordinate plane that do not lie on the same horizontal or vertical line. So they need to be diagonal from each other. Then find the distance between the 2 points. So if I just pick any random 2 points, let's say this point here and this point here, and I want to find the distance between those 2 points. Of course, the distance is the shortest distance there between those 2 points. And if I want to find the distance, then I can use the Pythagorean Theorem, which involves right triangles. But I'm going to have to actually draw a right triangle. So I could draw the right triangle here, like this. Make a right triangle. Or I could draw the right triangle like this. It's not really going to matter how you draw it, because either way, since we're on the coordinate plane and the coordinate plane is filled with a bunch of squares, we're going to have right angles, and so you can do it either way. And then so we can count our horizontal distance: 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 for our one leg, and then we have 1, 2, 3 for the other leg. And that's our vertical distance, the horizontal distance and the vertical distance. And then now we can use the Pythagorean Theorem. So a squared plus b squared equals c squared. That's the Pythagorean Theorem. 9 squared plus 3 squared is going to equal c squared. Of course, c is the diagonal line right there, the hypotenuse. And so 81 plus 9 equals c squared, and 90 equals c squared. And so our answer then, after we square root both sides, the square root of 90, the 90 is not a perfect square. It's between 81 and 100, so I know it's going to be between 9 and 10, and it's actually 9.48, or let's just say 9.5 when we round to the nearest tenth there. So we'll say it's approximately 9.5 units for the distance there. And so we can actually find the distance between 2 points in a coordinate plane by using the Pythagorean Theorem and using a right triangle. Now, what we're going to be doing today does not actually involve drawing on the coordinate plane. I'm not going to make you guys draw on the coordinate plane. Instead, we have a formula called the distance formula that helps us find the distance between 2 points anytime that we have those 2 points on the coordinate plane, even if we don't have a picture of the coordinate plane. So it's the distance formula is a version of the Pythagorean Theorem, and so I've got actually the steps here of how to find the distance formula. And so number 1, we're going to start with the Pythagorean Theorem, which is a squared plus b squared equals c squared. And then what we're going to do is, instead of calling this side of the triangle c, we're going to call it d for distance. We want to find the distance between these 2 points here on this triangle: x1, y1, whatever that point is, and x2, y2, whatever that point is. So we're just replacing the c with a d for distance. Now, in our last problem up here, I'm going to zoom out just a little bit so you guys can see a little better. In our last problem, we had to find what the vertical distance and what the horizontal distance was. We found the horizontal distance first, and we said that that was 9 up here on the top, and then we said the vertical distance was 3. And so to find that without having a picture of the graph, all we have to do is subtract x2 minus x1, and then take the absolute value of that, because distance is always positive. Whether you're going up or down, you're still moving one way or the other. So we always want a positive answer, which is where these absolute value symbols are here. So if I subtract the two x coordinates, x2 minus x1 will give me the horizontal distance. And then the y2 minus y1 will give me the vertical distance, and that'll tell me how. So our vertical distance up here was 3. That'll tell me the two values of basically the legs, if you will. So this is our a squared. That's why I colored it blue. And this is our new b squared. So again, To find the value of a squared, we have to subtract the two x coordinates to find a horizontal distance, our horizontal leg, and then to subtract the two y coordinates to find our vertical leg, which is our b squared. And then to find the distance, we have to square root both sides, right, to get rid of the squared there. So we square root both sides so that d is no longer has an exponent there. And then what we can do now is we can get rid of the absolute values and put parentheses. And the reason we can put these parentheses here is because anytime you square a number, and we've talked about this, your answer is always going to be positive. So I don't need the absolute value symbols to tell me that my answer needs to be positive, because if I'm squaring it, it's automatically going to be positive. So to recap, I know that was a lot, and really you don't need to know all the different steps of this, but I do want you to know that the distance formula comes from the Pythagorean theorem. So again, just a small recap. We're calling the hypotenuse d for distance. Okay, we're replacing a with the horizontal leg, which we subtract the two x values to find the distance of that horizontal leg, and then we're replacing b with the vertical distance of vertical leg, which you subtract the two y values. Everything else is the same. We're still going to square those numbers, and we're going to square root at the end to find out what the distance is. So compare what we have here to what we did in the first problem up here. Our horizontal distance was 9. Well, why was it 9? Well, this point was -4, -2, and this point up here was 5, 1. And so if I subtract my two x values, 5 minus -4 is 9. And so that is our leg, our horizontal leg. And then for our vertical distance, we subtract the two y values. 1 minus -2 is 3. And so that's where this part here comes into play, right? We're actually just finding how long those legs are without having a coordinate plane to draw on. And so this is the distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, let's do a few examples using the distance formula. I have the distance formula here, and I've actually got it written underneath the problems that we're going to do. Let's start with example A. I'm going to call this x1, and this is that would be y1. And we'll call this x2, and this one y2. Now, the order that you write these points does not matter. If I want to call this x1 and y1, that's fine. It doesn't make a difference at all. Just be consistent. Make sure you're not calling this x1 and this y2. That would mean you get a wrong answer. So the order you do it in does not matter. So D equals the square root of x2, which is -4, minus x1, which is 1, squared, plus y2, -2, minus 5, which is y1, squared. Okay, now I'm going to find out what's in these parentheses. -4 minus 1 is -5. And -2 minus 5 is -7. Now I'm going to square these values. -5 squared is 25. Remember, we're always going to have a positive number there, so that's, you don't need those absolute value symbols. And then -7 squared is 49. When I add those together, 25 and 49 is 74. And the square root of 74 is approximately 8.6. Now, this is very important. Please make note of this. I made a note on your homework so you would get this. When you are using the distance formula, Big Ideas does not want you to round to the nearest tenth. They don't want you to do that. If the number you get inside the square root symbol isn't a perfect square, they just want you to leave it as the square root of 74. So this would be our answer if we were doing this problem on Big Ideas. You would just write the square root of 74. And you can use the Big Ideas text function to use that square root symbol. 8.6 is correct. They just don't want you to write it like that because they don't want you to have to write an irrational number. And we know Big Ideas does not like irrational numbers. So they don't want you to have to, even though we could round it, it doesn't want you to do that. It wants you to leave it as square root 74. Now, if you were to get, for example, the square root of 81, go ahead and just say that's 9, right? If it's a perfect square, go ahead and find the square root. But if it's the square root of 74, we're just going to leave it as that. All right, for example B, we'll do this again. I'm going to call this I'm going to call this x1 and y1 and x2 and y2. And I'm going to write the distance equals, the distance between these 2 points. Notice I'm doing this without a coordinate plane, which is why the distance formula is so handy. x2 is -1 minus x1, which is 4, squared. So I'm subtracting the first two so I can find the distance. And then I'm putting a plus sign between them because it's a squared. Remember, this is a squared plus b squared. So there's a plus sign between it. And then y2 is 7, and y1 is -5. Now we know 7 and -5 is the same as 7 plus 5, which is 12. We know -1 and -4 makes -5. We're going to square root these. After we find the square of them first, -5 squared is 25, and 12 squared is 144. And then when we add those together, we get 169, which is a perfect square. So we're going to go ahead and take this all the way down to 13. The distance between these 2 points on the coordinate plane is 13 units. So I made this note here in case you didn't hear me the first time. Please note this. If you end up with a non-perfect square under your square root symbol, Big Ideas would prefer you leave your answer as a radical, which means just leave it as square root 74, and not round your answer. So don't email me about that tomorrow. Make sure you pay attention to this video and to the notes that I left, that note that I left on your homework. So you have quite a few, I think 9 homework problems. I shouldn't say quite a few. That's not too terrible. They're all very similar to what we just did in those last 2 examples, but I wanted to give you some help with number 24. Number 24 says your teacher wants the class to find the distance between 2 points, 2, 4, and 9, 7. You use 2, 4 for x1, y1, and your friend uses 9, 7 for x1, y1. Do you and your friend obtain the same result? Justify your answer. You and your friend are both going to get the same result, and I'm going to prove that to you right here. If I do what you do and use the 2, 4 for x1, y1, then that means then x2, 9, minus x1, which is 2, squared, would go right there. And then we would do y2, which would be 7, minus y1, which would be 4, squared. And that's going to give you 7 squared and 3 squared, which is 49 plus 9, which is the square root of 58. That's what you would get as your answer. Your friend, if you reverse this, if they do 9, 7 for their x1, y1, then they would get, let's see, 2 minus 9 squared plus 4 minus 7 squared. 2 minus 9 is -7. 4 minus 7 is -3. And we have to square both of these. And you can see right here why we're going to end up getting the same answer. Because when I square -7, I still get 49, just like I did over here. And when I square -3, I still get 9, just like I did over here. So they're also going to get the square root of 58 as well. So to fill in the blanks here, because we're squaring these numbers, it doesn't matter if it's going to be positive or negative. It does not matter if the differences are positive or negative, because when you square the numbers, the answers are equivalent.